Hi, this is Dr. Goff Louie for Element 14, and today I'll be talking about using Raspberry Pi to control your oscilloscope, an application note by Tektronix. So, automating your oscilloscope can have many benefits. Instead of sitting there at your bench using the oscilloscope interactively by twiddling its knobs and hand writing down results, you can automate all of that with a computer. In essence, the computer commands the oscilloscope to perform a certain sequence of tasks through remote control commands and collects the results remotely, thus making it easy to perform sophisticated experiments automatically and repeatably. So this is a very powerful tool which you can use to make certain experiments just that little bit easier and to make better use of your oscilloscope. So for today's demonstration, we'll be using a Tektronix 2 Series MSO along with a Raspberry Pi 4, and I'll be showing you how to set it up based on this application note. So let's take a closer look. Most oscilloscopes, including the 2 Series, have a number of ports which can be used for remote control. One of the more common ports nowadays is the USB port, which allows the oscilloscope to act as a device which a host can then control over USB TMC or sometimes USB CDC. Another common port, which higher-end equipment may have, is the Ethernet port, which allows for the instrument to become a node on a local area network and thus allows it to be controlled over longer distances and perhaps by many hosts, which allows for better sharing of instruments. So in order to get started with remote control, we're going to have to plug it in. So let's grab some cables and get the USB port and the Ethernet port connected, although really you can just get by with just one. Okay, the next step is to prepare your Raspberry Pi. So we've got a Raspberry Pi 4 here with a snazzy heatsink. The first thing we need to do is make sure we've got a suitable micro SD card, one which has been loaded with the operating system. In this case, it's Raspberry Pi OS, 64-bit edition with the full fat software. The next thing is to make sure we've connected the Raspberry Pi to its accessories. So I'm just going to connect it to Ethernet. I'm going to connect the oscilloscope, keyboard and mouse. And another thing we'll have to connect is the monitor output if we're going to use it interactively, which for this demo we are. And once we apply power, it will start up. And there we go, we can see it starting up now. So the first part of this will be to just set up the Raspberry Pi. Here I've got a fresh installation, and so we're going to go through the setup process. And then after that, we will have to set up the software that is related to the oscilloscope. But before that, let's power up the oscilloscope as well, so that it's ready for when we have everything set up. And through the magic of editing, we're now at the desktop ready to go with some software installation. So the first thing we're going to do is open up our terminal and type in some commands to do some software installations. So what this does is it just downloads the latest package lists and then it does any outstanding upgrades if there are. Now, since we've just upgraded our system, there shouldn't be anything there, and we are returned to the prompt. The next step will be to install a few Python 3 modules, and in this case we'll be using PyVisa as the library, PyVisa Pi as the Visa handler, and PyUSB to connect to USB instruments. So it tells us that this is an externally managed environment. So why don't we try, and this will be installing it from apt, and it turns out that it will also install PyVisa Pi and Python 3 USB, which is exactly what we wanted. So let's just do it this way. It's a little bit different, but it should also work just fine. Now that that's been installed, we also need to add in some permissions. So we're going straight into super user, and what we're going to do is just type in this line here, which should allow the user to have the permissions to access USB devices. So, and then we will exit out of super user and then reboot the system so as to apply these changes. Now we are ready to move on to the second part of this guide, which is to set up the connection with the 2 series oscilloscope. So in order to do that, we'll need to go back to the terminal, and we'll need to just make sure that the oscilloscope has been detected. So there we have it here, Tektronix MSO24, that is our oscilloscope. So the next step is just to test the connection, and that can be done by opening an instance of Python 3. We import PyVisa, we invoke the resource manager, and we ask it to list devices. And we can see there, it returns one device, which is my 2 series oscilloscope. So that's excellent. So what I'm going to do is I'm just going to copy this into the clipboard. And then I'm going to try and make a connection to it. Okay, so now I can then try to query the identity of the instrument. And there we go. So it responds, I'm a Tektronix MSO24, which is exactly what we expect. So we can see that communications is definitely working. So that's a very, very simple test of the connectivity. It doesn't really do much. The application note also does have an example script, which I couldn't actually download online, but I do have a copy. The spacing is a little bit mangled, so hopefully it'll work. So let's just exit out of this. So now it's time for the big moment. I have the probe compensation signal hooked up to channel 1 on my 2 series MSO. I have the copy and paste issues fixed with the example script. I've inserted the correct Visa resource string into the script so it will connect to the oscilloscope. Now I just have to run it and it will connect to the oscilloscope, pull the data, and then display very nicely on my screen, figure 1, channel 1 has the nice square wave, which is exactly what we're expecting from the probe compensation signal. So that's a good demonstration of just one of the things that remote control is capable of doing. So an optional step is to install TightVNC, and that is a virtual network computing server, and that allows us to remote control the screen of the Raspberry Pi from another machine on the same network. So what I can do is just update and upgrade, and then what we can do is install TightVNC server. Okay, we'll just say yes to that so that it installs. And then we will have to do the initial setup. Okay, so we're going to type in VNC server to start it up, and we're going to have to put in a password and put it in again, and that is not a view-only password. Okay, so now with TightVNC server installed, I found that if you run it with sudo, then you are able to get it to work. In which case, any other device on your network that has a VNC client on it can, in theory, remote control your Raspberry Pi. So I can access the Raspberry Pi, open programs remotely, and not need to be sitting at it. So that allows a level of remote access, although it isn't actually remote accessing the same session, so it might be a little bit confusing. It's actually spawning a separate session. So another option for remote control, instead of using TightVNC, is to use the inbuilt real VNC server. You can access this through the Raspberry menu under Preferences, Raspberry Pi Configuration, and within it you should be able to select Interfaces and toggle on the VNC server. Click OK to apply this configuration and wait a moment as the server is started. There we are. So you can see now on the phone there is the screen of the Raspberry Pi. I can say open the menu and go to say Internet and open a browser, and you can see there as it's loading the browser that's loaded on the screen behind me is also loaded here on the phone. So I'm seeing a live remote view. Anyway, this has just been a quick introduction to remote controlling your instruments. In this case, a Tektronix 2 series MSO. There are plenty more things you can do with remote control. It's really down to the commands that are available in that programmer's manual, and your imagination. This is a very powerful tool, so all the best for your remote controlling adventures. This has been Dr. Goff Louie for Element 14. Thanks for watching.